All right, welcome back to 105. So, not trying to use that microphone. Can people in the back hear me okay-ish? Good. All right, so today we are doing input and output. By the end of today, you'll be able to write your first program that can actually do anything. So, remember, that's the whole goal of programs. We want them to do something. We want them to make our lives easier. They're a black box, right? They take some input, they do something magical that's useful to us. In this case, our black box is going to be the programs we write, and then they produce some output that, is the result of doing some work for us. So, we're going to figure out today how to do input and output to use in our program. So, if we revisit our first program, we already did one side of this equation. We already did a bit of output. So, again, that include std.io, shorthand for standard input and output. It contains the declaration of that printf function, which is used for output. It will display that sequence of characters to our terminal for us. So, that printf function outputs technically a string, which is a sequence of characters. So now we know what a character is. A string is just a sequence of characters that hopefully form words or sentences or something that makes sense to us. So note, they should always end with a new line, which is \n. Same as hitting the enter character or the return character, or pressing send if you're doing a text message or something like that. So you always have to remember to press send to be polite. And then the string is that hello world part, which in C, strings are double quotes. So a character is single quotes, that's one single character. A string, which is a sequence of characters, always starts with double quotes, followed by any number of characters you want. And then another double quote signifies the end of the string. And here you never see the double quotes. If you want to see a double quote, you have to escape it like what we saw before. If you want to print a double quote, you have to do \, double quote. Just like for a character, if we wanted a single quote, we had to do a \, single quote. So functions can take input and produce output. So technically, if we want to start speaking like a C programmer, main is a function that takes no inputs. That's what void means again, which is a special type. And it produces an int value as an output. For functions, if you are a programmer, typically we don't call them inputs, we call them function arguments, but they mean the same thing. They're basically the inputs to a function. And in C, they're separated by commas if there's more than one. So far we haven't seen more than one, but today we will. So printf takes a string argument. We'll see what its exact type is later. Just know that it's a sequence of characters for now. And it technically returns an int value of how many characters were shown to the terminal, although we just ignore the output of printf for now. The nice thing about printf is it does all the work to actually show the characters in the terminal for you, so you can actually read the output. Another term, if we want to speak like a programmer, running a function is called a function call. So you could say, I made a function call to printf whenever I use printf. It's another way to speak about it. So printf technically accepts multiple arguments or multiple inputs if we want. So we could rewrite our hello world program to be something like this. So we could do printf and then a comma to signify we want another input to this function, and we could give it something like the value 1, which is again an integer like we saw last time. In this case, it will still print hello world. It kind of ignores that 1, but today we'll see how to actually tell C to use that 1 so that we can actually see that value as well. So technically when we do this, printf can now use that value 1. Again, like I said, that value 1, the type is an integer. So to use or to actually get C to use that value in the output, we can use something called a format string in order to print the values. So if I change hello world to be the string double quotes integer colon and then this %d, what C will do is replace this %d with the characters representing the value of the first argument of printf. And the first argument of printf has a special name to it. It's called a format string. So if you set up the default code space and you saw printf, it tells you the name of the first argument. You might have noticed it says format. It's because they gave it the name a format string. So in that format string, the % character is an escape character for the format specifier, so it only interacts with the printf function, and some format specifiers we'll use. Usually they correspond with how to output a value for a given type. So %d, that you can think of it as a decimal number, or it will output a bunch of digits. So that is used to output an integer. %lf is to output a double. And you might be like, well, that's a weird name for it. So how to remember this is, remember double is technically double the size of something called a float, which allows you to have a decimal. And double is double the size of a float. The LF is supposed to stand for long float. Again, don't ask me why, that's just what it stands for. So again, you don't have to commit too many things to memory, but you probably need to commit these format specifiers to memory and what types they correspond to. But you'll probably get some practice doing it in the labs and so on. And then the last one is, if I want to print a character, I can use $C, and that's for a character. And like for, escaping a string, if I want to use a % in my output, I have to escape it, so I have to use %. If I want a literal %, so if I'm outputting something like, I don't know, you got 98% on the exam, I would have to use two % signs to output a single % sign. So printf accepts multiple arguments, and here is our first example. So if we run this, if we run this, we'll see the output integer 1, and the rules for it is the values are always used in order. So the first value we give printf, it will correspond to the first format specifier in this printf string. So in this case, it would correspond to this D, so they have to match that. 1 is an integer, so its format specifier must be $D. If you mix and match them, it will still work. It will just look a bit strange. So these values are always used in order. So if I wanted to print, 2 or something like that, I would have to do the $D after it. So after running this, you will see integer 1 in your terminal. So any questions about that? So now we're able to display the values of integers, which is kind of cool. Whoops. So actually, let's see an example. So you can also mix and match if you really want to. Some weird things might happen, some weird things may not happen. So in this case, let's say I have an example where I say the integer value of the character A is $D. So this expects, the first argument to be an integer. That's how it will try and interpret it. But if I actually give the first argument as a character, well, it doesn't really match. So I would maybe expect this to print the integer value of A is A. But since I used the $D format specifier, it's going to change that into an integer for us. And it's going to match, the ASCII value that we assign to that value A. So if I go ahead, compile, and run this, it's called print A, I'll see that the integer value of A is 65. So if you look it up on the ASCII table or whatever, that is defined as what the number is that corresponds to the letter capital A. So you have a now built-in excuse. If you ever get a 65 in your course or something like that, you can be like, hey, no, I was just talking ASCII. I actually got an A. Don't worry about it. So 65s can be very good. I don't know. Terrible joke. So if you want to have it match, you would have to use the %C specifier if I wanted to print a character instead. So if I change that to a C, now instead of seeing a number, I will see that character represented actually as a character, which is probably something more that you expect. So because this is C, I have to recompile it. And now if I run it again, it will actually output the character capital A because, well, now I told C, hey, please interpret this character as an actual character. So now it will print a single character instead. So any questions about that or anything else fun you want me to do with this, or are we all good? And if I want to print other things, let's say I want to print multiple values, I could do something like 1, 2, and then let's just change my string. I could just say something like x is %d, y is %d, and now this will be done in order. So if I compile and run this, I should see that x is equal to 1 and y is equal to 2 because it will go always in order. So let's compile this, print it again, and now I see x is 1 and y is 2. So I can do this as many arguments as I would like. So any questions about that? So that is how to output some variables.
Wait, I have a question.
Yep.
Are we not just able to like end the string and then just add the variable x and then continue the string, or do we have to use these format specifiers?
Yeah, so you're wondering if we can just, you know.
After you do x colon space, if you put a double quotation mark and then do plus and then x and then plus and then start a new string.
Like if I do
Yeah.
something like that.
Yeah.
So if x doesn't exist, so I'd have to define x, like a variable called x. So I cannot do this. You could do this in some languages, so I'm assuming you knew Python? Java? So C is very, very different. You are not allowed to do this in C. If I try to compile it, whoops, I need to save it first. So if I try and compile this, it will yell at me with a lot of stuff that doesn't really probably make sense to us yet. It says adding int to a string does not append to the string. So probably don't know what that means yet. And here it says a whole bunch of other stuff. Invalid operands, some weird type. This star, we don't know what that is yet. And this, basically not allowed to do that. So we have to just use one big string here. It always has to be one big string using the format specifiers. We can't just add variables to it or anything like that. They have to come at the end there.
So like even the one, like you can't replace the %d with just 1? Or is that?
So I can replace %d with like 1, but that would be 1 in the string. Yeah, which is essentially just hard coding it, right? So I could also replace this 1 here with a variable. So if I wanted to, let's go back. So if I wanted to output the value of a variable, let's say x is equal to 5. Well, instead of using the value 1 there, I could use a variable instead. So I could just use x there. So now if I run this, I should see x is equal to 5, right? Because this, it will use the value of x, which if I look up, the last thing I assigned to it is 5. So it should print off x is equal to 5 and y is equal to 2. So if I run that, I'll see x is 5, y is 2. So now I can actually see the value of my variables. And if you're coming from Python or Java or something like else like that, might be a bit weird. This is how you have to do it in C. So any other questions about this or weird things you want me to do? Can't do anything terribly weird yet. Yeah?
Just wanted to ask, like, instead of x, if it was like a string variable, could you add
instead of if x was a string variable.
Like, you had like a string plus x plus string.
Yeah.
Like, if that x was like a string variable, would you be allowed to append it?
Yeah, so the question is, if x was a string variable, could it append to it? And the answer to that is, we won't get into exactly how a string is represented in C until about halfway in the course, and the answer to that is no. So we'll get to it. C is very, very finicky. Java and Python and stuff do a lot of things for you without you actually knowing what they're doing. C is very, 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 very explicit. All right, other questions before we go to the next bit of this? Yep.
So if you make a new string variable for your format string and it is collated and then you pass the string variable in as your format string, will C accept that?
So if one of these arguments is a string?
No, I mean like for the format string,
Yep.
you make a new variable, like let's say it's called string. And then for that variable, you use collation, so you do something like quotation mark x, close quotation mark plus a variable.
No. So the question is, can I just make a variable and do like a string plus x plus a string or something like that? And the answer to that is also no. But we'll see how to modify strings much later in the course. Yeah.
What's I was just wondering, like, what would be a format specifier for Boolean variables?
For a Boolean variable, you can just use %d and then it'll be 0 or 1. Yeah. Yep.
So because characters are represented as ASCII numbers, if I put %d, but my argument is a character, does it print the integer representation?
Sorry?
So, like, if I percentage d, right?
Yep.
And my argument is now a character.
Yeah.
Does it print the ASCII representation?
Yes. Yeah. So if I do %d and then I give a character here, like b, there's some disagreement here. It will interpret that b as an ASCII number, so it'll convert it to a number because the format specifier is how you want it displayed. So I want it displayed as a number. So I want this character displayed as a number. So C will just interpret it as a number, and it's just, there's that number mapping from before from the ASCII table, so I'll get the ASCII value. So if I go ahead and run this, I should get 66, because that's the ASCII value of a capital B. Yeah. Yeah, the question is, does it work the reverse way? And the answer to that is yes. And this shows that, C or computers are just a bunch of magical numbers, right? So if I do the number 65 here, and I say, please output that as a character, then I'll do it the reverse way. So I should see as my output, x is equal to capital A here. So like with everything in computers, it's just how you want to interpret that data. Everything is a 1 or a 0 at the end of the day, right? But just that probably makes more sense. Like if I was calculating grades or giving you a letter grade, I'd probably want to use a capital A instead of a magical 65. Because if you come back and read it, you might be like, what the hell is a 65, right? All right, anything else with this? All right, cool. So here is another example for that, for outputting multiple variables. So let's say I wanted to represent maybe a point. So I have an x and a y. I could declare and assign x is equal to 1, y is equal to 2. So this is just another way to do that. Instead of what I did before, just inputting 1 and 2, I could, again, use variables for both of the arguments. So again, they will always go in order. So x will correspond to the first format specifier. So I want to print this x as a int, and I want to print this y as an int. Usually, your format specifier should always match the same thing as the type you want to print. Otherwise, you might get confusing results and it might not be exactly what you expect. So again, if we go ahead and run this, we should see 0.12 in our terminal. So the other part of this is how to get input from the user. So there is another function called scanf, and that lets you get input from the terminal. Basically, think of it as the opposite of printf, because it also thankfully uses a format string, so you only have to keep track of those 3 format specifiers. So it's slightly different that instead of using a value, it assigns to a value. So it will do the assignment to the value we tell it. And because this is C and it's very low level, it's going to look a bit strange, and we have to talk about memory a little bit. So technically for printf, you need to use the starting memory address of the variable. So remember, if I have an int that takes up 4 bytes, it's somewhere in memory taking up 4 bytes. Remember, memory is byte addressable, so every single byte has an address, basically a house number, that corresponds with where that byte is in memory. And for a int, it will have 4 bytes in a row to represent that integer. In this case, if I wanted to use these, well, in this case, the starting address of this variable is 512,004. It would be a royal pain in the butt if you had to figure out what the location of this variable was in memory yourself. Thankfully, C gives us a way to get this value without you actually having to see it. So, yeah, without having to see it. So, you can use an ampersand on a variable to get the starting address of a variable. We will come back to this about halfway through the course. So just know that ampersand and then the name of a variable gets the starting address of the variable. It's going to be some giant number. We don't really care what it is. We just need to know what it represents. So if I have int x, the percent sign is something called a unary operator. If you're used to mathematical operations, where negative x or something, it's a unary operator where it just flips the sign of the x. So the ampersand character is also a unary operator, so it only acts on a single variable. So in this case, I could do ampersand x. That means give me the starting address of x. So again, unary only requires 1 operand. Addition, like everyone is familiar with, technically is a binary operator, so it takes 2 arguments. So plus needs a right-hand side and a left-hand side, right? So that's why it's called a binary operator. So the result of the ampersand is a new variable with a new type. We won't talk about what that type is yet. To see what that type is, it's just going to be the original type with a star at the end of it. Star has a certain meaning. Again, it just represents the starting address of that variable in memory. So technically, the type of ampersand x in this case is int star. Again, don't worry about this for now. We won't actually have to use it. We'll get into more details as we go on. So this is how I would use it. So now I can use our terminal for input and output. So I can do something like this, where I say printf. So printf is output to the user. Usually if you ask the user for some input, or usually if you want some input from the user, it's a good idea to tell the user what you would like them to enter. So here I do a printf that says input x as a number. Then I declare a variable called x, and then I can use scanf. So the way scanf works is like printf. It wants a format specifier, but it goes in the opposite direction. So instead of using that value to display something, it actually assigns whatever the user types in to that variable, all in order. So this means I want to interpret whatever the user typed in as an integer, and I want to assign that variable to x. And to do that, I have to give the starting address of x so C knows where to actually write that value to. For reasons, again, we'll get into later. So after the scanf line, after the user types something and presses enter, whatever they typed will be stored in X, and then I could output, let's say I output whatever they type. So let's go to example, make sure it works when we run it. So here is that same code. So I'm going to have a printf prompting the user to input X. So I don't use any format specifiers here. I'm not printing any values. I'm just telling the user, please input X. And to make it look nice, I'll just do a colon and then a space after that because the next characters are going to be whatever the user types. So then I declare a variable called X, do scanf, waiting for the user to type a integer. Let them type an integer, and then whenever they hit enter, it will assign whatever they actually typed into to the variable X, and then I just output whatever they typed in. So if I run this program, what I call it, IOX, it will say input X. So again, our programs will always execute from main and go line by line. So I can see, based off the output, saying input X, this line executed, I saw input X, then my program declared a variable called X, and now it's waiting for me to type something in. So it's doing this scanf function, waiting for me to type something in. So now I can give my program a bit of input. So let's say I give it the value 42, hit enter, and then what scanf is going to do is assign that value 42 to that X, and now I can output X using, again, the same %D format specifier to print the value of X. So in this case, it should just output whatever I inputted. So any questions about that? Yep.
You said that when we say like int main void, it means that basically we're not taking any input, right?
Yeah.
So in this case, how are we able to give input using scanf?
Yeah, so the question is, well, with main, right, it says, like its inputs are here, and it says void, so it has no input. So how am I getting input from scanf? So for C, there's different ways to get input. For the function arguments for main, that's the input to the main function, which doesn't take any inputs. And scanf allows us to get inputs from the terminal, which is a different source. So when we run our program, main doesn't need any arguments because it just starts running. Our program just starts running. And then scanf gets input from the terminal, so it gets it from a different source. So we'll see a way much later in the course, I don't think it's technically covered in the course, to get input from main, but we'll just ignore it for now, and we'll use scanf to get input from the terminal instead. But good question. Yep?
So in this case, we didn't have to compile it?
We did compile. Yeah, I compiled it.
Oh.
Yeah, sorry, I just skipped that step. It was already compiled. Yep.
Input like a character.
Oh, okay, yeah. So what about if we input a character? So let's say I do this, and then I lie to it and say, hey, you know, I'll just input a character, oh no, C. I'll get some weird, gigantic negative value because it doesn't agree with what I typed, and it will try and interpret a C as an integer, and weird things will happen, especially with the input. So for this course, we'll assume that the input will always be valid, and you don't have to do any error checking or anything like that. But if you disagree with it, you'll get some very strange output, as you might see there. Yeah?
Could you explain again what the ampersand does in this code?
So the ampersand, after that, oh, the ampersand? So that just gives the starting address of that variable. So how C works, if we just give, like, we can think of it, if we just give it the value of X, that doesn't do anything. So that would be like, so say I give it, say I set it equal to 0, and then I give scanf that value 0, it can't actually change that value of 0 to anything useful, right? You just give it the value of 0, and then C's like, I don't know, I can't assign a 0 to, like I can't assign whatever the user types in to 0. I can't change what 0 is. So the rules of C is you have to tell it the memory location to change. And how to do that is that %, that gives me the starting address of that variable. And then C is like, okay, whatever the user types in, I will change the value at that memory address for you. So for now, we'll just kind of hand wave over it and just know that for scanf, it needs to know the starting address of that variable to change. So always use ampersand for any of the scanfs. All right, any other questions? No. All right, cool. Let's flip back. So now we can use our terminal for input and output. Again, here, this scanf there converts the characters we type to an int, assigns that value to x using its address. That's why we had to use the ampersand x there. So scanf also technically returns the number of values assigned. Note that the type of the arguments and the format specifiers should always match. Otherwise, you'll get very unpredictable results, like when we type C and we expected an int. Sometimes it's okay to use different types for printf, like what we saw before to see the integer value of a, interpret it as a number. That's okay. Typically in this course, they should always match unless you have a very good reason for them not to match. So if I wanted to create a more useful program, so let's try and create a more useful program. We can create variables that do not change as well. So we can declare a variable by adding a const, what C calls as a keyword before the type. A keyword in C is just a word that's reserved for the compiler, so I can't name a variable something like const. So it's just reserved by C, you're not allowed to use it. So if I wanted to set the value of a variable to something like 1 and make sure it'll never change, I could do something like const int x equals 1. Now, if I do that, I'm not allowed to reassign x. So it's usually good practice to add const to any variables that should never change. And the compiler will yell at you if you try and change a variable declared as const. So some other rules are you should be consistent with variable naming. So normal variable names should always start with a lowercase letter. And instead of a space, the recommended style for this course is you should capitalize the next word instead of adding a next space. And const variables should start with a capital letter to indicate that there's something that should not change. There's some special values as well where every letter is capitalized and the words are separated by underscores instead, just a different style. So having a consistent coding style is also very important. The C compiler ignores white space. So it's just for you to read. There's a formatter for you, part of the lab 0 instructions, but you should also know the rules. So function definitions like main start at the beginning of the line. And every time you start a new set of curly brackets, so the curly brackets, you need to indent the next lines, which just means move any text 4 spaces over. So every level of indentation, every time I have a new set of curly brackets, I add another 4 spaces. For now, we only have 1. That's why my code has been formatted, with 4 spaces for any of the statements within main. So let's skip over here. Let's just delete this, pretend you didn't see this. So let's try and write our first useful program that will, let's try and write a program to convert inches to centimeters. So whenever we develop a program, we probably want to think of our inputs and our outputs. If we're writing a program to convert inches to centimeters, well, my input is probably a length that should be in inches, and my output is a length that should be in centimeters. So, next thing, I know my input should probably be, the length in inches. My output should probably be the length in centimeters. I should think about what types I should use for both the inputs and the outputs. So for the input of inches, anyone want to tell me what the type of that should be? Yeah, I heard double. So probably let the user actually input something with decimals. So I'll create a double for my input, and I'll call it inches. So that is what I want to get from the user. So I can go ahead and I could actually go ahead, prompt the user to enter in the length. So I can be nice and say enter length in inches. Do something like that. And then in order to get input from the user, from the terminal, what should I do if I want to, actually have the user input something to this variable called inches? Scanf, right? So scanf, what should I do as my format specifier for it? Anyone remember? Yeah. Yeah, %lf. So I want it to go into a double. That format specifier was %lf. And now I have to tell it the starting address of the variable to change. So again, we just have to remember that ampersand. So I want it to set to ampersand inches. So let's look all right to everyone. All right. So my next step is my output. So my output should probably be the length in centimeters, right? What type should that be? Probably double again, right? So double centimeters. So how do I convert inches to centimeters? Anyone remember what the conversion is? Yeah? Multiply by around 2.5. Yep, so it's inches times, it's 2.54, I believe. So if we wanted to convert it to inches to centimeters, it's just inches, and in C, multiplication is just a star. So we're assigning the value of centimeters to inches times 2.54. Now, if I want to output the result of this calculation, what should I use? You can just yell at me if you want. Printf, right? So printf, I should do maybe output something like the converted length in centimeters. All right, so let's pretend I have amnesia. What do I need to do here to actually output the value of this centimeter variable? Anyone hand up to help me? Yeah. Yeah, so first thing I'm writing is the format specifiers for my string here. I know I'm trying to print a double, so that format specifier is LF. So I probably want to put it here. What's the other part I need? Yeah, just comma and then CM. So I want to actually output the value of centimeters. And again, it's in order. There's only one format specifier. So the value of CM gets replaced by this format specifier, which will actually print it as a double. And of course, I have to end with a semicolon. Otherwise, the compiler is going to yell at me. It always has to end with a semicolon. So I can compile and then try and run this, inches to centimeters, our first useful program. I don't know, someone give me a length. What do we want to convert? What I hear, 6.5? Sure, 6.5. So if I do 6.5, I got 16.530000. Kind of works, right? Seems to be all right. It's a decent program. Any questions about how this program works before we go into trying to improve it a little bit? Yeah.
If you input like another decimal place, do you get an output which is like more precise?
So if I input another decimal point, so if I do like 6 point this, then yeah. So I'll get way more decimal points there. And we can actually round that if we really want to. Yeah.
So it's always 6 though, but it's like you're only 6 numbers after the decimal point.
Yeah, so by default, it's always 6 numbers after the decimal point, but we're going to see how to change that for one improvement. Because maybe we think that's ugly or that's way too many decimal points that we actually need. All right, any other questions? Yeah. Why 6 numbers? That's just the default. Sorry, there's no better answer than that. All right, well, so if we were to improve this program, usually for this program, this 2.54, that is something called a magical number. So knowing this is a pretty simple program, so you know that's probably the number of centimeters per inch, right? But when you program using something like magic numbers, it's typically a bad idea. You should try and give names to these magical numbers so they make more sense. So one improvement might be to do something like, hey, I'll create a new variable called double inches per cm, and then maybe I set that value as 2.54, and then in here, instead of using that magical value, I can do inches per cm instead, like that. Yeah?
So before when you had it hard-coded, can I say that the 2.54 wasn't stored in memory anywhere? Or is it stored somewhere?
So
Just have it as a...
the question is that 2.54, when I just had it hard code there, is it stored in memory or not? And the answer to that is likely it is not going to be stored in memory, but we're not going to worry about that for this course or if something's in memory or anything like that. So I would argue that this is probably a more readable program. Any other suggestions for how to improve this program to stop me from doing anything silly? So remember, there's that const keyword for things that shouldn't change. Should inches per cm ever change? Probably not unless we change the definition of an inch or a centimeter, which, I don't know. Knowing Americans, they might change the definition of inches. Who knows? But typically, if I do something like inches per cm and then do something like now it's equal to 5, I probably shouldn't be allowed to do that, right? Seems like a bad idea. So if I wanted to, one thing I could do is I could take use of that const keyword. So I could say const double inches per cm because I don't expect it to change. And if I'm keeping in line with my coding style, since it's a const now, I should change it, the starting character from lowercase to uppercase, which means I should also change this. So this is probably a better written program because now it doesn't use any magical values and now it is constant. So now if I compile and run it, should still behave the same. 5.4, I get, the correct answer. And now if I did something like silly, like I tried to change inches per cm to 5 or something like that, you might notice this little red line. So now when I compile, I'll see that I get an error. It says cannot assign to variable inches per cm with const qualified type const double. Basically, that's just saying that variable is a const. You are not allowed to change it. It is an error. The C compiler will actually help you out and make sure that you actually can't compile your program if you try and change, the definition of inches per cm. So, any questions about that? Perfectly good program. All right, let's do some other quick fun things too that I will show you. So technically a double contains approximately 16 decimal places. The format specifiers have sub-specifiers to change how they print that value. So for numbers after that starting ampersand character, we can put a dot followed by a whole number to indicate the number of decimal places to print. For a float, even though a double actually stores 16 decimal places, by default it will just print out the first 6 of them. So there's a full list of specifiers at c++.com. That's a link in the slides that you can go ahead and follow and see what the other ones are. So one of the fun format specifiers, again, just to change the number of decimal places, is if I only wanted 2 decimal places for the centimeters, I could just do .2 right after the ampersand, and now it will only print 2 decimal places. So if I do that, compile again, and now run my program and do, I don't know, something with a lot of decimal places for my input, my output is always going to have 2 decimal places. And it should be noted here that this %2, it doesn't actually round the value stored in centimeters. That's still storing up to 16 decimal places. So it doesn't make that variable any less precise or anything. All I'm changing is how it's presented to the user. So I'm only printing 2 decimal places, but that double is still storing all 16 of them. So questions about that? Okay. Other thing I could do as a slight improvement is to not, like I said, using magical numbers typically isn't a good thing. Technically returning 0 here, that's a magical number. I just told you that indicates nothing bad has happened. If I want to get rid of that as a magical number, what I can do is there is another include I can add called stdlib.h, and that's short for standard library.h. So it has a bunch of other variables and functions from the standard C library. One of them is a whole bunch of constant numbers to use to represent, whether a program has failed or succeeded. So if I want to get rid of this magical variable, this header file has a variable or a value called exit success. So if I wanted to get rid of that magical variable, I could use exit success instead. You can see here, if I mouse over, it says provided by stdlib.h, and really it's just an integer with the value of 0. But if I didn't want to remember that 0 indicates success, I can use exit success instead if I wanted to, if this makes our program more readable. You might start off using this, and then when you get more familiar with C, you'll just know that, hey, 0 means success, non-zero means failure. I can do whatever I want. So there's exit success and also exit failure. Failure is just a 1. But for now, all our programs should probably end in success. So any questions or anything else you want me to do with this? So first program, it actually does something, right? So now it took our entire first week, but now we can start writing useful programs. So now we can start asking interesting questions and start working on Labs 1, which will be released very shortly. So we can take our extra 2 minutes